Hello students, this is Ravi, chemistry lecturer. Today I am going to explain JW Mains 2024 January questions from hydrocarbon chapter. First question, which of the following compound will most easily be attacked by an electrophile? So here one is benzene, toluene, chlorobenzene, phenol. Out of these, benzene, no, without any substituent. Here CH3 is a substituent. The third, chlorine. Fourth, OH. OH is when benzene is attached to OH or OH group is attached to benzene, then the compound is phenol. Phenol is more reactive than chlorobenzene, toluene, and benzene. That's why phenol is easily attacked by an electrophile. Option 4 is the right answer. Second question. Given below are two statements. Statement 1. The NH2 group in aniline is ortho and para directing and powerful activating group. Statement 2. Aniline does not undergo Friedel-Crafts reaction, even either alkylation or acylation. In the list of the above statement, choose the most appropriate answer from the options given below. Check statement 1. When NH2 is attached to benzene, then the compound is considered as a aniline. Here on nitrogen atom there are two non-bonding electrons, one lone pair. This involves in resonance. Then pi bonding electrons will shift on the adjacent carbon on ortho carbon. So that's why negative charge will create an ortho and para carbon. That's why it is a ortho and para directing group. Statement 1 is correct. Next, aniline does not undergo Friedel-Crafts reactions. Why? Because during Friedel-Crafts alkylation, we are going to use anhydrous AlCl3, aluminium chloride. So, aluminium chloride will act as Lewis acid. And here, due to the presence of lone pair of electrons on aniline, it will act as Lewis base. Now these two react each other. Actually, that the benzene ring should undergo substitution reaction, but instead of that, NH2 group reacts with anhydrous AlCl3 Lewis acid to form a salt. That's why aniline does not undergo Friedel-Crafts reaction. Statement 2 also correct. Now check option. Option A, both statement 1 and statement 2 are correct. First option is the right answer. Next. Question number 3. The total number of deactivating groups in aromatic electrophilic substitution reaction among the following is. First one, it is a ester group, that is -M group. Here amide, it is amide plus M group. Amine, it is third compound is amine. Amine also plus M group. Nitrile plus M group. OCH3 plus M group. Sorry, here nitrile is -M group. Deactivating group. Plus M groups are deactivating groups. Plus M groups are deactivating group. So out of these, plus M, amide 1, amine 2, and ether OC3, methoxy. So total number of deactivating groups 3. Right answer is 3. Next, fourth question. In the given reactions, identify A and B. H2 reacts with A in the presence of PDC, gives rise to alkene. The next reaction, alkyne reacts with sodium and liquid NH3, gives B. When alkynes reacts with liquid NH3 in the presence of sodium, will get transalkenes. Here carbon atoms 1, 2, 3, 4, 4 carbon atoms. Then we'll get alkene with 4 carbon atoms. That should be in trans form. Trans, total number of carbon atoms 4, that's why but 2ene. And here the alkene is obtained alkene in first reaction, that is cis. So cis obtained from alkyne when you use Lindlar's catalyst. So that's why A is pentyne, 2-pentyne, CH3, C triple bond, C single bond, CH2, CH3. When it is treated with PD and C, gives cis alkene. That's why option A, 2-pentene is A and B is transbutene. Option A, option 1, right answer. Question number 5. Total number of isomeric compounds including stereoisomers formed by monochlorination of 2-methyl butane. Take a structural formula of 2-methyl butane. It is 2-methyl butane. So first, to find the products, identify the different types of different types of hydrogen. 1, 2, 3, 4, and it is 5. Now, if chlorine is attached to first carbon, then we'll get one product. In this product, there is a chiral carbon at this position. That's why it will show 2 isomers. One is plus, another one is minus. Next, if chlorine is attached to second carbon, we'll get the same structural formula. Next, at third, here no chiral carbon. Next, at fourth carbon, then we'll get a chiral carbon. It is a chiral carbon. Here also we'll get 2. And another one is at fifth carbon. Yeah. So here total number of isomers including stereo 1, 2, 3, 4. Here 2 and here 2, right? That's why here 1 extra and here 1 extra, 6. So 6 isomeric compounds will obtained in this reaction. Next, 2-methyl hex-2-ene on reaction with HBr in the presence of peroxide forms an addition product. The number of possible stereoisomers for A. Hex-2-ene on reaction with HBr in the presence of peroxide forms an addition product A. The number of possible stereoisomers. To find the answer, take a reaction 3 methyl hexane 1, 2, 3, 4, 5 and 6. At second carbon methyl group, at third carbon methyl group and at second to third double bond. Now add HBr in the presence of peroxide. Then addition of bromine takes place at lower degree carbon, at second carbon takes place. Then we'll get this product. Here in the obtained product there are 2 chiral carbons. Then we'll get 4 stereoisomers. For even number of chiral centers, 2 to the power of n. Here n is equal to 2. 2 to the power of 2, that is equal to 4. If you didn't subscribe my channel, please subscribe and like and comment. Next, question number 7. Among the following, total number of meta-directing functional groups integer based. So here NO2 is a meta-directing group, CN is a meta-directing group, COR is a meta-directing group, COOH is a meta-directing group. Total 4 meta-directing group, remaining all are ortho and para-directing groups. Next, question number 8. The final product A formed in the following reaction sequences. First, PH CH double bond CH2 reacts with BH3 in the presence of H2O2 followed by oxidation in the presence of H2O2, that is hydroboration reaction. Hydroboration gives alcohol pH CH2 single bond CH2OH, alcohol will get. Next, HBr gives pH CH2CH2Br. Next, magnesium in the presence of ether gives pH CH2CH2MgBr Grignard reagent. It is treated with formaldehyde, gives alcohol, secondary alcohol, that is pH CH2CH2OH. The same one, pH CH2CH2OH. Option 4 is the right answer. Here after hydrolysis, when Grignard reagent reacts with formaldehyde followed by hydrolysis gives alcohol. Next, major product obtained in the following reaction. Simple. Here HBr, break a bond here, add H and here Br, and here Markovnikov rule, bromine to this carbon and hydrogen to this. According to that, the product is so OH, CH, single bond CH3 to this carbon bromine plus CH3, CH2, Br. The major product P. This is the major product. So here out of this first option is right. Sorry, not first option. Fourth option is right. Question number 10. The arenium ion which is not involved in bromination of aniline. Aniline NH2 ortho and para directing group. So here in third one, bromine is attached to meta, that's why it does not take place. Right answer is 3. Next, question number 11. Identify product A and B. So cyclohexene reacts with chlorine in the presence of sunlight. Chlorination takes place at a more reactive carbon, more reactive hydrogen. 2. At this position chlorination takes place. Next, in the presence of CCl4, addition of chlorine takes place. Cl and Cl. Here substitution reaction. Here addition reaction takes place. So then A is this one and B is 1,2 dichlorocyclohexane. So fourth one is right answer. Next, when you add water to this compound, then double bond reacts with water, undergoes addition reaction, forms alcohol, reacts with CrO3, oxidation takes place, then a secondary alcohol converts to ketone. Then when it reacts with NaNH2, NH2, hydrazine in the presence of KOH upon heating, Hoffman bromide degradation, then ketone group converts to C double bond O converts to hydrocarbon. It is ethyl benzene. First is the right answer. Next, 13th one. Consider the given reaction, the total number of oxygen atoms present per molecule of the product P. So this is the product P. Ozonolysis it is, followed by hydrolysis. Just break a bond here, add oxygen to the double bonded carbon atom C double bond O and here H and CH3. We'll get a 2 moles of product. Each one contains 1 oxygen atom. That's why answer is 1. Next, in the given reaction, identify the reagent A and reagent B. Here reagent A and here B. So this reaction, toluene is converted to benzaldehyde. Toluene is converted to benzaldehyde. So one is Itard reaction in the presence of CS2. Itard reaction takes place in the presence of chromyl chloride, CrO2 Cl2. Now that is equal to B. Here A is equal to CrO3, chromic anhydride or chromic oxide. Another method to prepare benzaldehyde from toluene. So now A is CrO3, B is CrO2 Cl2. So A is CrO3, B is CrO2 Cl2. Second option is the right answer. Next, 15th one. Compound A formed in the following reaction. Reactant B react compound A formed in the following reaction reacts with B, gives the compound C. Find out A and B. Here alkyne reacts with sodium, then sodium replaces the acidic hydrogen which is attached to terminal alkyne, gives salt, sodium salt of alkyne, C minus and Na plus. When it is treated with see here in this how many products, carbon atoms. So 1 2 3 carbon atoms. Take a haloalkane with 3 carbon atoms, CH3 CH2 CH2Br. Then Br replaces the sodium, then the carbon attached to this one, then we'll get CH3 C triple bond C single bond CH2 CH2 CH3. So now it is B and it is C. A is this one, sodium salt of alkyne. So now A is sodium salt of alkyne and B is CH3 CH2 CH2Br, CH3 CH2 CH2Br. Option 1 is the right answer. Next, question number 16. Product A and B formed in the following set of reaction. When alkene reacts with water in the presence of acid, forms alcohol, Markovnikov addition reaction, Markovnikov rule it follows. So now addition of hydrogen, addition of OH or water to the higher degree carbon. Next, in the presence of B2H6 and H2O2, anti-Markovnikov rule. Here Markovnikov rule, here anti-Markovnikov rule. OH is attached to lower degree carbon. So it is A and it is B. So here A, B. Second option is the right answer. Question number 17. The product C in the below mentioned reaction. When 1 bromopropane reacts with alcoholic KOH, gives alkene, CH3 CH double bond CH2. It is treated with HBr. Here the alkene is A. Treated with HBr gives bromoalkene. Markovnikov rule takes place. CH3 CHBr CH3. It is B. Next, upon heating with aqueous KOH, nucleophilic substitution reactions takes place. gives alcohol. Br replaced by OH. CH3, CH, OH, CH3. It is C. So now product C is prop 2 propane 2-ol. Propane 2-ol. Fourth option is right. Next, number of alkanes obtained on electrolysis of mixture of sodium acetate and sodium propanate. When sodium acetate undergoes cleavage, forms free radical, that is CH3 free radical. This one forms CH3, CH2, ethyl free radical. If 2 moles of ethyl free radicals forms butane, 2 moles of methyl radical forms ethane. When these two reacts, forms propane. Then ethane, butane, propane are the possible. Alkanes, one is ethane, butane and propane. So total 3 products are possible. Next, question number 19. Identify A and B in the following sequences. When bromobenzene reacts with concentrated HNO3, forms 2, 4, 6 trinitrobromobenzene. When it is treated with NaOH, then forms sodium salt ONA 2, 4, 6 trinitro sodium salt of benzoic acid, followed by acidification sodium salt of phenate. So simply you can call it as phenate, sodium phenate, followed by acidification it is converted to phenol. So 2, 4, 6 trinitrophenol. So A is 2, 4, 6 trinitrobromobenzene. B is 2, 4, 6 trinitrophenol, that is picric acid. So B is picric acid, bromobenzene. First option is right. Next, addition of HDCl like HCl. First add deuterium to this carbon, lower degree carbon, then chlorine to this carbon. Chlorine and CH3. In another product, Cl outside the ring, CH3 inside the ring. So here third one is the right answer. Number 21. The number of isomeric products formed by monochlorination of 2-methyl-butane in the presence of sunlight. 2-methyl-butane, 4 carbon atoms, 2-methyl-butane. So now 1, 2, 3, 4. If chlorine is attached to at first carbon, then here there is a chiral carbon, we will get 2 products plus and minus. If it is attached to second carbon, no chiral center. If it is attached to third, then here we will get 1 chiral center, here also plus and minus. If it is attached to fourth, yeah, so here 2, here 1, here 2 and here 1. So total possible isomers